Good afternoon, everyone. My name is Beattie, and I'm one of the directors of Beattie Passive. We've got Ron Beattie, the Managing Director, and Ken Mercer, the National Sales Manager, on the webinar as well. I'd just like to introduce you to the third of our webinars this series. The first one is on retrofit, second one on modular, and this one is on the Passivhaus schools. Just a bit of housekeeping. The way in which this will work Ron will present for probably about half an hour, and then we'll have the opportunity for Q&A. So please do drop any questions you have in the Q&A button at the bottom. We'll try and get through as many questions as possible during the webinar. Any that we don't get a chance to cover today, Ken will follow up with you directly to make sure we do get those answers to you, but we will try and get through as many as possible. So thank you very much, and I will hand over to Ron.
Great. Well, thank you very much for joining us, as Isabel said, in our third webinar. For those of you who have joined previously, I apologise for the next sort of 5 or 10 minutes where I want to explain really what Beattie Passive is about and what we are trying to do in the built environment and in the construction industry. About 11 years ago, I was building one of the Code Sustainable Home Level 6 developments, and came across one day walking around the scaffolding and realised that a bricklayer had put no insulation in the wall, and this was one of the real sort of forerunners of our Code Sustainable homes that we were trying to achieve. That led me to realise that it was impossible to build the buildings that we plan and design, and that really the performance gap has just grown and grown and grown, and there's no way that under the existing building processes that we do that we can deliver on the quality that we need to deliver to basically build homes as designed, but also meet climate change and the ever increasing problems we've got with energy costs. So Beattie Passive really set out to change the way we build and look at every element of that build. So very passionate about fire and sound and buildability and cost and longevity, where the materials come from, the embodied carbon and the in-use carbon, and also what happens to those buildings at the end of their life and how we can reuse the buildings to make new buildings. In fact, to reuse everything that we put into them. So quite a big tall order, really. And also out of that had to be that they could be built anywhere by anybody. And they all delivered to that criteria, which is the highest level that we could possibly do, but also to Passivhaus. And I'll explain to you later, for those of you who don't really understand Passivhaus yet. So with that in mind, I think that Beattie Passive is an innovation company, although we're building across many sectors, and I'll explain to those again in a moment. But we are about bringing new products to the market. And that means that we've got to stand up and look at each sector and say, why are we delivering it this way? And a lot of times what I get back is because we always have. We've always put one brick on top of the other. We've always put bits of insulation together. We've always get lots of different people trying to build buildings. And unfortunately, when we do that, we have the problems because no one really cares what the person done in front of them or behind them. And we're all too busy rushing around for our own lives and our own problems and our own cash flows and our own programs that it's really difficult to get it to work. So when you start to understand that, you need to start to understand the way that we need to change. And I think that Beattie Passive, its innovations and where it's driving in these sectors is sort of, I'd like to say, showing the way that change is possible, showing the way that we can actually build buildings that deliver 100% on their design criteria, can be built by young people and new entrants into the market and old entrants, but we can get these buildings built in time, on budget, and hopefully reuse these buildings in the future for many, many different things. So with that in mind, I'm going to start running through a few slides with you. We are patented in 42 countries, and we are in discussions with other countries around the world, New Zealand, Australia, America, about all of our products. And that allows us to control the quality and how it's built and how things are certified and tested. And I think that's really important that we can do that. And we hope that once Beattie Passive is getting more established, then we will start to roll out internationally. We've got 97 patents in 42 countries. And we've built up to now over 450 homes, and I'll say homes, probably 2 school buildings, but 450 homes across the UK, ranging from very large one-off houses, 8,000 square foot is the largest we've built, down to social and our House 4 range, which is basically for looking after homeless and meanwhile housing. So we've built across the whole breadth. And now it's the time to look at larger buildings, to look at how we build those large buildings, and if there's another way to do it. And that's what Beattie Passive is going to talk to you today, and say we challenge the market, and we believe there is better ways and cheaper ways and more efficient ways that deliver passive house of a way of delivering schools and many other buildings. These are just some of the buildings that we've built. Some are on the mountains up on the Isle of Man, as high up as you can reasonably get there, taking the wind loadings and that type of thing. With the big farmhouse in the middle on the right there, that's the 8,000 square farmhouse that was in fact hit with lightning when it was completed. Had a big test on fire then, which I'm pleased to say withstood it amazingly. And being a timber frame farmhouse, was no damage to the actual structure at all. So quite amazing, but a good test for the resilience of Beattie Passive products. And so many different architecture types, but realistically, Beattie Passive can build any building. It's a really simple way of building homes and schools and many other buildings. So our products, we've got our on-site delivery process where we can build on site. We've got flying factories, and at the moment we've got flying factory partners across the UK that are actually building our system. We do the design, we do the testing, but they actually carry out after a training course where they come, residential training course, and then 3 to 4 weeks on-site training and inspection, learn how to build in the Beattie Passive system. And there, of course, we've gone into volumetric off-site manufacture, which I think is really going to be a real boost to the construction market. It's not easy, like all things. We've got the planning, we've got hold-ups in the production chain and materials. So modular isn't the answer to everything on every site, but it's certainly a way of getting up a production, delivering on that same sort of quality of product and bringing more young people into the industry. So I believe that modular factories are going to be a real part of Beattie Passive going forward. And in fact, we're talking to 5 or 6 different partners at the moment about setting up regional factories where we can deliver our new build, our retrofit, and also potentially schools and things out of these regional factories, and not just one element. I mean, many, many different shapes and sizes of buildings. We've got our House 4 range, which is our meanwhile housing. And again, we're delivering large projects of 50 odd apartments, which are meanwhile, they'll be there for 5, 10, 15, 20, 30, 40, 50, 60, 100 years. But they can be taken down and moved. And that's an asset where at the moment we're spending a fortune on money, putting people in hotels. And I think the government is spending something like £1.2 million a day on housing in hotels for refugees. And with what's going on at the moment, that's only going to grow. So we need to rethink about those sorts of monies and put them back into assets that we've got forever and we can reuse instead of just wasting those sums of money. And then, of course, what I'm going to talk to you today is the schools and then a retrofit. And retrofit is just as important for schools as it is for other buildings. You know, we are spending a fortune heating our schools and we're not delivering on any of that carbon target. So retrofitting our existing school stock is absolutely important that we start doing that. And the reasons are not just about financial there, it's about the health as well, which I'll go through further on in this presentation. And then we've got our T-Cozy Plus, and that's about decarbonising the existing stock and putting more houses on top. That gives us a great win as far as land concerns, services, parking, across many, many properties across the cities of the UK. So as you can see, Beattie Passive have got quite a few products. Sometimes they say, well, why are you coming out with all these new products and not stick to one? We've got to change construction. And the only way we're going to change construction if we're bold enough to take the challenges on. You know, one of our retrofit projects at the moment is we're teaming up to deliver around the Grenville Tower estate, and we're doing testing with the council to look at all the products and how we test them all before they go onto that place. So we're going to have that sort of commitment in the industry to make things work and learn by our mistakes. And Beattie Passive is about doing that, making sure that we test and we deliver on the highest quality. So let's get back to our schools. I'm sure you're pleased with what you come to listen to. So climate change, a big one, undoubtedly. I mean, we're all facing it. We're facing it not only in the climate, but now on fuel costs. And, you know, that's going only one way. And like all things, it's never going to come down again to what it was. So we're going to face many, many years of extreme pressure on fuel costs. And if you look at what our budget is for heating schools, that's going to treble, and that's going to make a real difference to what we can deliver. So we've got to do it in a regeneration factor, and we've got to make sure that we pinpoint our money to get the maximum back from it. Air quality in schools, I'm sure that you know about. I mean, it's a major issue. It's a major issue in the way we're learning, the major issue in our children's health, and a major issue in a lot of things that are hidden in the old schools, like asbestos and radon gases, that, you know, 200 or 300 children a year die of actually just because they've been in schools that have got those issues. And of course, teachers as well. I think 300 teachers died last year due to different problems with their bronchial, but really cancers and that caused by asbestos or radon. So big issues that we don't like to talk about, but we've got to deal with. And then we've got the increasing cost. As you know, building costs are sky high. Material costs are just going up 20, 30, 40%. And so we've got to find a way of actually guaranteeing cost. And the only way we can do that is if we get guaranteed and we know what we're actually buying every time we buy it. And because every school that's normally designed goes through that design period and then a costing period and then a delivery period. And by the time it gets built, costs have gone through the roof. So we've got to find a way of meeting that. And I think that's where Beattie Passive is looking. It doesn't just try to sort out one issue. It looks at the whole breadth of issue around building and tries to make sure that we've got an answer for most of them. And then lack of supply of classrooms, 12,000 new classrooms needed in the next 2 years. And trouble is, we can build them in one location and for one school, and then someone puts a darn great big estate 3 miles down the road, and we need another 500 classrooms over the next 5, 6, 10, 20 years. So we've got this unknown amount, and I don't know how it happens so much, but we're always trying to catch up. And what we need is a plan that we've already thought about catching up. And we also got a supply that we can alter and change and move and make that work. So it's a really interesting scenario when you start to look down on each part of it. So Beattie Passive, I said, I've built over 450 units. We're a certified Passivhaus system, and we can modularize, and that's what we'll be looking at doing. How do we build schools that we modularize and we can just build in components? And if we think about it as a component, a classroom is a component in the school. A hallway is a component in the school. A toilet block is a component in the school. A staircase is a component in the school, such as a medical room or all of those bits that just need to fit together. And if we can do that, what we can then start to do is saying, how do we alter and change and move and have something that is always living and not something that needs to be one design with one system of M&E and one location. So we start to rethink the whole way that schoolings are built. And then, of course, we can then cut CO2 and heating as well. So that's a big one, that we can actually reduce the energy requirement for a school and also cut that CO2, which is massive. So Passivhaus, as I say, Beattie Passive was the first. I think there's someone else now who's got a certified system in the UK, but for many years we have been the only, and that's given us a real market lead on delivering Passivhaus. And as I say, we've done 450 odd, all built by different people, all supplied in different shapes. But these are the fundamentals of it, and the fundamental is an insulation that goes continually around the building. And unlike any other building system, Beattie Passive creates a void under the floor, on the walls, through the roof, and that void is pumped with insulation, be it bead or rock wool or any type 1 fireproof material. It pumps around the whole thing, so making the building not only very fireproof, but very well insulated with no joints. And that's the key, that continuous insulation. And we do that in our new build, but we also do that in our retrofit, where we go from foundation up over the building and we inject that insulation. And we're about, hopefully, to do over 250 across London soon. So for those of you who are really interested in retrofit, that'd be a great opportunity to come and see what's happening there. And again, for schools, It's an absolute must. We must start to think about that. So insulation that goes continually around the building. We then got triple glazed windows, so really high insulated windows that go into that frame. And then we use heat recovery ventilation. Now, heat recovery ventilation is a way of ventilating that room to a really high standard, between 6 and 8 air changes an hour. And that means that all the air that comes in that building goes through a heat chamber. And the hot energy, the hot air that we've created in that building, 80% of that goes across to the incoming air. So we're only looking at topping up 20% of that energy cost, and we all give off 100 watts each. So you've got lots of kids in the classroom, we'll be really heating that up really easily. So heat recovery ventilation is probably one of the best ways to give high quality ventilation into a schoolroom, because it's filtered. So we cut out things like pollen, and also the dust within that building is taken out. So they're a lot healthier environments. And one of the things we can talk about in a moment is that need and what that means to our children as they learn. Air tightness. Each Beattie passive home reaches Passivhaus at 0.6, up against something like 13 or 14 or 15. That means 15 times a day, 15 times an hour, all the air within that building is going to go out, and it's got to be put back up again with hot air or hot in the air to heat that air so we feel warm. You can imagine how many times you're doing that. In a passive building, it's 0.6, and we're reusing 80% of it. So the need for that heating is drastically reduced. So it makes those buildings Passivhaus really simply. And then we've got thermal bridge 3. And a thermal bridge is when we've got the cold and the hot hitting together. And then we get a transfer of that energy between the two, and we start getting cold spots, which ends up in mold and so on. So we have major issues that way. So they're the fundamentals of Passivhaus. And Beattie Passive, as I say, has been building passive houses now for the last 10 years, all section sizes, all delivering. And I know that one of the biggest ones we've done at 8,000 square foot, I think his heating bill was under £150 last year. It's got quite a few PVs, but nevertheless, you know, that's a sort of process. And we've had a house here, one of our test buildings here at our Norfolk factory on throughout this winter. And we've heated that with 1 kilowatt. And that 1 kilowatt come from a £15 B&Q little tiny 2-bar radiator. And that's the sort of heat and environment we need. You know, we don't need massive amount of infrastructure if we're only talking about a very small amount of energy to heat our homes and schools. So just quickly for those techie, these are the sort of U values that we, as our standard. It doesn't mean that we need to stick to them. We go down lower. We never go above, but we always go down below when required, because Passivhaus, we're looking at orientation, we're looking at window sizes. So we need to vary our U values. And 2 years ago, I built one at 0.07 for walls and 0.54 for the floor. So again, we can vary that down to suit the PHPP, but they're our modular U values. Air tightness is always 0.6 and below. Y value is actually minus. And our sound is something I want to go through later, but basically sound between dwellings is 6 times better than building regs. So you can have a party next door, you can hear kids singing, and you won't hear that in your own classroom, which is really important to the way that, again, kids get distracted and we learn. And then about fire. As I say, one of the projects that we'll be working on very soon will be Grenville Tower, and how we're sort of working with, looking at around, we're going to be retrofitting the existing stock, which is at the bottom of the Grenville Tower, of course, going to be under a lot of scrutiny. And and we've always been very much looking at fire protection in buildings, and all our walls are 2 hour one side. So between the classrooms, that'd be 4 hours protection between classrooms, whether it's above or beside each other. Right. As we know, I said before, we've got to get more energy efficiency into our existing stock and our new stock. So I think that's for said. You know, we know that. We also got to get constant temperatures, Our children will learn, and it's well documented now, that at around 20 degrees is the best static place for our bodies. And that means it's healthier for us to sit and learn. We're not too hot, which means that we're in a classroom that's stuffed up and we're trying to get heat into it. So we're getting tired. And we all know what it's like if we're in a meeting and we're sitting there by the end of the day and we're all worn out. In a proper ventilated room, you're going to be alert for a lot more. So we're looking at that 20 degrees. And the passive house is always around 21, so that's perfect for it. We're also looking for that sound, and as I said, if you look at most schools that are set around urban places where we've got cars, roads, some of those closed classrooms are trying to talk where you've got an external sound coming up to 86 dB. It's incredible. So, we've got to look at all our schools, and whether it's new build or retrofit, and get that drastically down. And as I say, Beattie Passive is some 6 times better than building regs. So it makes a massive difference to the way that teachers can teach their classroom. So not battling again, either inside or outside noise, and also how the children can learn and hear. Because I remember being at the back of the class and saying, I didn't hear that, miss. I didn't hear that, miss, when she asked me questions. So that's because I was deaf. But nevertheless, those are the sort of things we need to build into this. And then we want to look at the reduction in space heating, which of course is climate change and CO2. And in fact, I think it's costing £44 a pupil per year to give them adequate heating in a school. £44 per pupil per school. That's amazing. Now, if we can get that down by 90%, wow, that's a big difference to put that back into the learning and what we can do to build more schools. So really important. And our carbon footprint. I think with Beattie Passive, everything we do, we look at the whole embodied carbon. So we have run an analytic check of all the embodied carbon inbuilt and in use as well, and do a 60-year plan to actually show the maintenance and that plan, which gives us a massive, I think, lift in the way that we manage our carbon and our carbon footprint. And going back to that quality thing, really, the air quality and ventilation, which is so important. And what we're going to talk about now in a few moments is how we make that fit in individually. Because what we've done up to now is we've had massive, great big M&E, heat recovery ventilation systems that work for the whole school. They ventilate at one rate and they just on all the time. And that's a big waste of energy and a big waste of money, where we've got no one in the classroom, but we've got the classroom gone out to play sport. We've got people that are sick in one classroom, so they've had to go to another classroom and close it down. So we've got real issues here, the way we use schools in the future. And I think that's something that Beattie Passive today wants to start talking about. So, as I said, cost is a big issue. So if I said to you, I'm going to deliver you this glass of water, and that glass of water is going to cost you X this year, potentially X next year, and potentially the next year after that, and within sort of 5%, you're going to know that's what it's going to cost. That gives you a massive planning process. And by doing it offsite, by doing it modular, by doing it in a component fashion, then we'll be able to say that will be the cost. And at the moment, we're seeing inflation running, I think last year was 24% in building costs. So, a big difference, and we don't know what it will be, of course, with all the issues we've got at the moment, what it's going to be next year. So massive changes. So simple classroom. All of our schools are all made up with the same classroom. All of our schools have toilet blocks. All of our schools have hallways. All of our schools have a headmistress room and an office and a care room, hospital care room. So why do we redesign them all the time? Why do we sit there with a new piece of paper and say, I want a school? And yet we draw the same size classroom, the same size hallway, the same size utility rooms, and we do it all the time. And then we have this great big M&E structure that we fit all around it, and we say, right, lovely school, well done. Let's go and do another one. And we start again. That's what we've got to stop. We know that if we make a classroom of X 58 square meters, 60 square meters, that takes 30 children, we're going to make that again and again and again. So we can start to think about how we join them all together, how we make them self-supporting individual units that plug together. So if I wanted to go out and look at how schools are made now, in my mind, in Beattie Passive, it's about how do we make that component that they all fit together. So my client that's in Rotherham has got a classroom for class, and he's got 100 children, and someone in Leeds may have 200 children, and someone in Scotland may have 800 children. And all we need to know is how many classrooms you want, how much circulation space we need. Do we want it first ground floor, first floor, third floor? And then we can actually make that actually just bolt together really simply. So from a single classroom with one classroom to a secondary school with 40 classrooms, exactly the same, no different. All they do is just plug together. So we've got individual heat recovery ventilations at £1,200 each. We've got pipe work that goes around that individual classrooms. We've got singular electric heating system. We've got IT and BIM management and all the infrastructure to go behind that, fire that individually into each one, just plug in. So that allows us to build schools and change schools to whatever size we want to in the future, instead of being stuck with this one fits all. And if I'm not using 30% of that school because of some reason like COVID has happened, then I don't use it. If I don't use 50% of that school, I don't use it. I can lose one classroom in that school and still the building will be as efficient as it is. Rethinking all this is just so important than the way that we thought of buildings before. We need to really throw the rule book out and look at how we can do energy efficiency and real building design that works. So, very simple. Classroom, hallway, and a toilet block. So if I said to you how many classrooms you wanted in a school, you would say to me 10, 20. And again, we just build that with you. Sit down and build those things with your architects to see how that all fits together. There is no reason that it's not clad in brick, it hasn't got timber, it's not clad in any way. The roof could be pitched or monopitched or flat roof, that doesn't matter. It's just building those building blocks together to give us the best way of delivering a school of the future that was going to give us that CO2 reduction, a healthy environment for our youngsters to work in. So this school I'm just going to show you was drawn up with one of our architectural partners, G&A Architects. And this is very simply 6 classrooms, 5 admin sections, 6 halls, 2 lobby sections and a sports hall. And the sports hall is made, of course, it's a big thing. So that's a steel frame. And then we've got our modular off-site manufactured panels that go around and they link in to the existing school. Because we're going to pump through that insulation, we can do some modular, some on-site if it had to be, and some as an off-frame scenario. So basically you've got that unit and it can all come down again if it needs to and move on or be added to. So the same process, same build system, whether it's stick built, panel built or complete modular. And that makes life so much easier when you've got tricky junctions and things to deal with. So a very simple school layout, but one that I'm sure is replicated throughout the UK. That's it in a simple SketchUp model. And as you can see, each classroom's either aspect, double aspect of those. You've got a hallway that runs through the middle, admin block in the middle of that, and that could just be picked up and re-altered and changed. So we're going to sit down with our clients and say, right, you know, how does that best fit the site? We know the parameters that we're dealing with. We know the size of classrooms. We know the size of hallways. We know the size of staircases and toilets, but we redesign it every time. So that's where we feel we've got to change. This is something we're just finishing down in Cardiff at the moment. And these are actually meanwhile houses. This is a few months ago, so it's moved on a bit more since then. But our block, the small block down the right, which is block A, is in fact a creche. It's a training area. These are for homeless people. That could be there for a day or 100 years, that development. There's 1, 2 and 3 bedroom apartments. And there's a whole administration and care facility that's going around that development for Cardiff Council, which is a wonderful idea. And in fact, the government is at the moment spending £1.2 million a day on refugee accommodation in hotels. For 7.5 days of money, you've got that development there. So I think government need to break up and see that's an asset you've got forever. We haven't just wasted £1.2 million a day. You're actually delivering something that you've got forever. And the economics are just madness if we don't do more and more of this type of thing. But as you can see on the floor plan, we've got a large creche there. We've got a teaching environment there. We've got interview rooms and care rooms. So this is the sort of thing that we're delivering to Passivhaus, zero carbon at the moment. And this development, I hope that, again, if some of you want to come and visit this class facility, then Ken will pick that up with you after this presentation. But we're doing it, we're delivering it, and it's working. And so it's a very exciting opportunity to actually show you what's happening at Beattie Passive. So why Beattie Passive? I think that really it's around quality. It's around having something that is going to be the future of building. It's about a new way of delivering. It's about a whole new way of supply, and about young people in the industry. You know, we need to fill our factories and I think with new young blood to build the house of the future. We lose 400,000 people a year out of construction. And we don't put anyone back. We've got to re-educate and get people back into schools who understand where they're living and what they're doing and help build those skills of the future and retrofit the existing stock. So an immensely interesting, exciting and process for Beattie Passive. So I'm very pleased that we've started to look at schools as a big part of what we're doing in Beattie Passive. So very exciting. Great. Well, I hope that was an infill into where we are at the moment with our school building programme. If there is any questions for us, then please bring them over now. I'll be happy to answer them.
Okay, thank you, Ron, for that. So we've had a couple of questions through already, so I'll start with those ones, and then please do drop any more questions down in the Q&A box. What is the maximum unsupported span that you can achieve with modular school classrooms at all? Okay, so at the moment our span in classroom is 12 metres in timber. Can be a bit longer in steel, but we won't transport it. So basically we're looking at what we can transport. In the school halls, what we're looking at there is a porter frame, because of course we've got larger, very tall buildings that we won't be able to transport. So there we've got just a steel porter frame, and then we put the frame over the top of that. Thank you. Someone has asked, will the modules have bearing point loads that are supported on concrete pads? Yes, again, they're lightweight buildings. Depending if you're going 2-3 story higher, then you're going to want a foundation around the perimeter. But realistically, they're lightweight. A building will weigh no more than probably 12-14 tons, so they can be put out on pads. Okay, and actually a connected question to that one was, what is the typical concrete pad size, assuming good ground conditions? Yeah, 600 by 400 mil deep. Depending on the ground conditions, but that sort of size of pad. Okay. Next one was, how long do you need on site to build a standard size primary school? Well, that's a difficult one to answer, but you know, if it's all pre-manufactured, the services are in, then it could take anywhere between 14 and 20 weeks. Okay, perfect. Question from Nikos is, how easy is it to extend the school with additional classrooms in the future, and how does that work? Okay, so if you can imagine each classroom is individual. All services are individual, it's plug-in. So each one's got its MVHR unit, each one's got its IT, each one's got its water, each one's its fire, each one's got that type of bit integrated into it. Then all we're going to do is add another one. And the hallways have got a service void through them where they just add into the MVHR. So basically they've got their own system. Every 4 they get another MVHR system. So they can all just plug in. Fire extinguisher, fire thing, the main runs are through and they just taper off, plug in again. So we're looking at ways that we can just add another floor. Everything is this, again, you haven't got to add a whole floor. You could add half a floor and then just shape that and then add another floor in the future. So it's really around thinking of each component as being totally independent and adding those together. Thank you. What is the lifespan of these buildings generally?
Okay, so it's 60 years plus. I mean, we design stuff to last. These are buildings will last hundreds of years. They're open cell. The water won't affect the buildings if it got into it. It's all treated timber and steel as well. So we do work in that as well. So realistically, 60 years. Any building design is 60 years plus, and Beattie Passive is the same, and it comes with warranties the same as any other building would.
Okay, thank you. Just another question on renewables. Can renewables be incorporated?
Oh, most definitely. Everything we build now should have photovoltaic cells. Everything we should build should be as energy efficient as possible. So yes, again, if we're using PVs, we put them on the roof, we can take them off and then put them on the next level and add more to them. So very important that we put as much green technology around our schools as possible.
And what about, obviously you've shown us having flat roofs. Can they be pitch roofs?
Of course, no different at all, just the design. So yeah, pitch roofs are absolutely fine.
Okay, thank you. So we're going to move through these questions quite quickly. The other one was just around mechanical ventilation and maintenance.
Sure. Well, a big one again, if the maintenance is in a single classroom, then it's basically to walk in, take the filters out, put the new filters in, and can be checked easily. And it's individual. So, you know, it's a really simple thing to walk around, do something which is just basically a very small unit, than a huge MVHR ventilation system that's running a big school. They're huge things and really technical. And if that goes down, of course, it's a real issue. Where if one classroom goes down, you can just potentially move into another classroom or share a classroom. If school goes down, you've had it. So it's all around thinking about all of those things that really can affect us, because we're doing stuff on such a big scale with so many different air changes, and it's a real problem. Cut it down to one little classroom, becomes really simple.
Thank you. In terms of external finishes, I think you touched on this slightly, but can the external be changed for anything in terms of planning purposes?
Yeah, absolutely. It's basically we create a ventilation void, rain void. Any moisture goes in there will just fall down and it'll be ventilated. And out the outside of that, you can have brick slips. You could brick up the front if you wanted to. You can have timber, render board. Makes no difference to the Beattie Passive structure at all.
Okay. Les has asked, do schools have BOPAS certification?
Yes, or everything comes out of the factory. It's not the school that gets the BOPAS, it's the factory that gets the BOPAS that it comes out of. And Beattie Passive are a BOPAS accredited delivery system.
Yeah. Another question we've had is around embodied carbon. So what about the embodied carbons in construction materials?
Yeah, as I said before, it's timber mostly. So again, very good for embodied carbon. We do an embodied carbon assessment on many projects. So that will be done. That will look at all the materials as far as the inbuilt carbon is, and also what the in-life carbon is as well, and give you a 60-year life of that.
Okay, I think we've probably answered most of the questions that come up now. So doing a good selection across all areas. So I think that's covered all of the ones who've been asked. If there are any others, then Ken will be very happy to come back to you. So please do get in touch with Ken. He'll be sending a follow-up email, sharing the recording should you want to forward it to anyone else, your colleagues, or you looking for more detail. But thank you very much for your time, and we look forward to speaking to you soon.
Lovely. Well, thank you ever so much.